Tonight you are going to lose something. Not money, not time, something you have never questioned because it never occurred to you that it could be taken. You are going to lose your certainty about what is real. You wake up every morning and the world is there. Solid, heavy, predictable. The floor holds your weight. Coffee tastes the way it tasted last week. You do not think about any of this. Nobody does. The reliability of reality is the one assumption underneath every other assumption you have ever made. Without it, science does not work. Memory does not work. Cause and effect do not work. You never question it. It would be like questioning gravity while standing on a cliff. Over the last 30 years, something has gone wrong in the foundations. Not in one place, in 4. Quantum physics ran experiments that shattered the rules of observation. Information theory discovered that the substance underneath matter is not what anyone expected. Mathematics proved that knowledge itself has a hard limit. No intelligence will ever break through. And neuroscience found that the one thing all of this depends on, the observer, cannot be explained by any physical law we have. 4 disciplines, none of them working together, none of them solving the same problem. Different decades, different instruments, different continents, and the same conclusion. A conclusion that does not match what you were taught about reality, that does not match common sense, that does not match the feeling you get when you press your hand against a table and feel it push back. This is not one theory by one controversial physicist. This is a pattern found by people who were not looking for it. The pattern says reality operates by rules, not the rules you learned in school, deeper, stranger, rules that determine what can exist, what can be known, and what will stay hidden no matter how hard you look. Rules that no one wrote for us. And we are only now beginning to see them. The first one was found in a physics lab. The experiment is so simple, a high school student can build it on a bench. And so disturbing that 100 years later, no one has been able to explain what it means. You fire a single particle at a wall with 2 slits. 1 particle, not a beam. 1. It passes through and hits a detector on the other side. You do this 1,000 times, 1 particle per shot. When you look at the detector, you see stripes. Light bands alternating with dark bands. In physics, this pattern only forms when 2 waves collide and cancel parts of each other out. But you did not send waves. You sent individual particles, 1 at a time. Nothing else was in the chamber. The only way to produce those stripes is if each particle went through both slits simultaneously. 1 object, 2 locations, at the same time. Thomas Young first showed this with light in 1801. Klaus Jonsson repeated it with electrons in 1961. In 1999, Anton Zeilinger did it with molecules made of 60 carbon atoms, objects large enough to image under a microscope. Every time, the same result. A single object existing in 2 places at once. You change one thing. A sensor at one of the slits. It does not block the particle, it does not touch it. All it does is record which slit the particle passes through. You run the experiment again. 1,000 shots. The stripes vanish. The particle behaves like a bullet. 1 slit. 1 path. It stopped splitting the instant information about its path became available. The sensor applied no force. The equations are specific. What changed was not energy or momentum. What changed was the existence of a record. When nothing registers which slit, the particle takes both paths. When anything registers the path, it takes 1. The particle does not respond to force. It responds to information. It responds to the fact that something knows. The floor you are standing on is made of particles that follow this rule. The screen in front of you, the air in your lungs, all of it made of objects that do not commit to a definite state until something observes them. Right now, they are definite for one reason. You are here. You could say this is a quirk of measurement. Some physical interaction the sensor creates that we have not fully mapped. That was the standard objection for decades. Then, in 1982, a physicist named Marlon Scully designed an experiment that destroyed it. Scully asked a question that sounds almost childish. If the particle changes behavior when information about its path exists, what happens if you erase that information after the particle has already passed through the slits? The particle has already traveled, it has already hit the detector. The event is over. Scully wanted to know whether deleting the record would change what had already happened. In 1999, Yoon-Ho Kim built the apparatus. The answer broke something fundamental. When the witch path information was erased after the particle completed its journey, the interference pattern came back. The stripes returned. The particle retroactively behaved as if it went through both slits. Not because anyone changed the past, because information about the past was removed from the present. The record was gone, and the particle acted as though it had never chosen. It did not care about the sensor. It did not care about physical contact. It cared about one thing. Does information about my path exist anywhere in the universe right now? If yes, I am a bullet. If no, I am a wave. This question is not answered at the moment the particle moves. It is answered at the moment you check. The past reshapes itself around the present state of information. This is not a fringe result. It has been replicated worldwide. It is called the quantum eraser, and it tells you something about reality that most people never hear. The issue was never the detector, never physical interference. The issue is information itself, whether it exists, whether it is accessible. That single variable determines how reality behaves. Everything you were told about the past being fixed, about events being settled once they happen. This experiment says otherwise. The past is not written in stone. It is written in information. And information can be erased. You could still contain this. You could say it is a property of tiny particles in controlled environments. Photons are strange, electrons are strange, but the real world, your world, the one with gravity and morning light, that world is solid. It does not shift based on what you know. In 2007, a team working on one of John Wheeler's thought experiments proved that this comfort has an expiration date. John Wheeler was not a fringe thinker. He coined the term black hole. He worked on the Manhattan Project. He supervised Richard Feynman's thesis. And in 1978, he proposed an experiment so unsettling that it took 30 years before anyone could build the equipment to test it. The idea was simple. Take the double slit setup and delay the choice. Do not decide whether to measure the particle's path until after it has already passed through the slits. The particle enters the apparatus, travels through, and only then, after the journey is complete, you flip a switch. If you choose to measure, the particle behaves like a bullet. If you choose not to, it behaves like a wave. The decision you make in the present determines what the particle did in the past. In 2007, Vincent Jacques and his team built it using single photons and fast optical switches. They confirmed exactly what Wheeler predicted. The photon's behavior at the slits, an event that had already occurred by the time the switch was flipped, changed based on a choice made after the fact. The present reached back and shaped the past. In 2015, an Australian team scaled it up with helium atoms, heavier and more complex. Same result. The weight did not matter. The delay did not matter. The present rewrote the past every single time. This is no longer about photons being strange. This is about time. You treat the past as settled. You assume that what happened yesterday is fixed, stored, done. Wheeler's experiment says otherwise. The past does not finalize until the present makes a decision about it. The past is not a fact. It is a draft that gets edited every time new information enters the picture. 3 experiments. The double slit says reality responds to observation. The quantum eraser says it responds to information, even retroactively. Wheeler's delayed choice says the past itself is open until the present decides what to measure, each one worse than the last. But all 3 share one limitation you could still hide behind. They involve single particles, tiny objects in sealed labs. The next experiment removes that wall. It won a Nobel Prize for doing it. In 1964, A physicist named John Bell sat down with a pencil and proved something that should have ended every comfortable assumption about the universe. He did not need a laboratory, he needed algebra. The setup involves two particles created together in a single event, linked by a property called entanglement. You send them in opposite directions. They travel far apart, kilometers. Then, you measure a property of one. The instant you do, the other particle, no matter how far away, shows the correlated result. Not after a delay, not after a signal, instantly, as if distance does not exist. The natural response is to assume the particles agreed on their answers before they separated. Like two coins programmed to land the same way. Bell proved this is impossible. His theorem shows mathematically that no hidden instructions carried by the particles can reproduce the correlations that experiments actually produce. The numbers are too strong. They violate a precise inequality that any pre-programmed system must obey. Alain Aspect tested this in 1982. The results matched quantum prediction and violated Bell's inequality. No hidden instructions. In 2022, Zeilinger, Clauser, and Aspect received the Nobel Prize for closing every known loophole. Two particles separated by any distance respond to each other instantly. No signal, no force. The correlation is not transmitted through space. It exists as if space between them is not real. 4 experiments. Reality does not commit to a state until observed. It responds to information, not force. The past is not fixed. And distance is a suggestion it ignores. This is the most tested body of predictions in history. It has never been wrong. But underneath all 4 results, one variable keeps appearing: information. The particle responds to whether information exists. The eraser works by deleting information. Wheeler depends on when information is created. Bell's particles share it with no regard for space. What is information? Is it just a bookkeeping tool? Or is it something physical? Something you can weigh? In 1961, a researcher at IBM answered that, and the answer changed everything. Rolf Landauer worked at IBM in the early 60s, building some of the first transistor circuits. He was not thinking about the nature of reality. He was thinking about heat. His computers kept overheating, and he wanted to know why. The answer he found had nothing to do with wiring or voltage. It had to do with the relationship between information and the physical universe. Landauer proved that every time you erase a single bit of information, the minimum possible amount of heat is released into the environment, not because of friction, not because of resistance. Because erasing information is a thermodynamic event. The formula is kT multiplied by the natural logarithm of 2. K is the Boltzmann constant. T is the temperature. The number is tiny. For 1 bit at room temperature, the heat is almost immeasurably small, but it is not 0, and it cannot be reduced below that line by any technology, any cleverness, any future breakthrough. It is a law. For 50 years, this was theoretical. Then, in 2012, Antoine Berroux and his team at the École Normale in Lyon measured it directly. They trapped a microscopic bead in a double well potential and erased its positional information. The heat matched Landauer's prediction exactly. Information is not a metaphor. It is not an abstraction. It is not a useful way of talking about things that are really made of atoms. Information obeys the laws of thermodynamics. It produces heat when destroyed. It is physical. Go back to the 4 experiments. The particle responds to information. The eraser reverses reality by erasing information. Wheeler depends on when information is created. Bell's particles share information across space. And Landauer proved that information is a physical quantity, bound by the same laws that govern engines and falling objects. This changes the question. If reality responds to information, and information is physical, then information is not a description of reality. It is the raw material, the substance underneath. One physicist said this explicitly. 2 words. Those 2 words rearrange the entire hierarchy of what is fundamental and what is not. Those two words, word from bit. John Wheeler, the man who named black holes, who helped build the atomic bomb, who trained Richard Feynman, arrived at this after a career that touched every major branch of 20th century physics. He looked at the evidence and said it plainly. The bit comes first. The physical thing comes second. Every particle, every field, every force you have ever encountered is, at bottom, made of information. Not described by it, made of it. You have been told the opposite your entire life. You were taught that the universe is made of matter, and that information is something humans invented to talk about matter. A label. A filing system. Wheeler reversed this. Matter is what you get when information arranges itself into a stable pattern. The atom is not the foundation. The bit is. In 2002, Seth Lloyd at MIT treated this as an engineering problem. If the universe is a computer, it has been running for 13.8 billion years. It has a total energy budget. It has a minimum clock speed set by the Planck time. You can calculate how many operations it has performed. The answer is 10 to the power of 120. That is not a metaphor. It is a number derived from measured constants. The universe is not similar to a computer. It is one. Every particle you see is a result of that processing. Your hand presses against a table. You feel solidity. You feel the wood resist. But your skin never touches the surface. The atoms in your fingers and the atoms in the table are separated by a gap nothing crosses. What you feel is electromagnetic repulsion between electron clouds. The sensation of hardness is a signal your nervous system builds from a pattern of forces. You have never touched anything in your life. You have only received information about things. If information is the substance and not the description, it must have limits. A hard drive has a maximum capacity. If the universe runs on data, there must be a ceiling. A maximum amount of information any region of space can hold. In 1973, a graduate student found that ceiling in the last place anyone expected. Jacob Bekenstein was studying black holes. A black hole is the simplest object physics has ever described. It has three properties: mass, charge, spin. Everything that falls past the event horizon, every book, every planet, every particle, gets stripped to those three numbers. Bekenstein wanted to know how much information a black hole could store. The answer should have been simple: bigger volume, more storage. That is how every container works. A warehouse holds more than a closet. But when Bekenstein ran the math, the answer came back wrong. The maximum information in any region of space is not set by the volume. It is set by the surface area of the boundary around it. Every room you have stood in has an information limit. Every planet, every star. And in each case, that limit is written on the outside, not the inside. The boundary determines what can exist within, not the other way around. Stephen Hawking reached the same result from a different direction 1 year later. He proved that black holes radiate. They emit particles at a rate tied to the surface area of their event horizon. Information does not escape from the interior. It leaks through the surface. 2 physicists, 2 methods, 1 conclusion. The data that defines a volume of space is not stored in the volume. It is encoded on the surface wrapping around it. You are sitting in a room. You see depth. You see distance between your body and the far wall. 3 dimensions opening around you. But every bit of information that makes that space is written on a 2-dimensional boundary. The depth is not stored inside the room. It is computed from flat data. The 3 dimensions you experience are being generated from something that has only 2. You are inside a projection that has convinced you it has depth. If the data lives on a flat surface while you perceive volume, then volume is not fundamental. It is output, rendered. The question is what reads the flat data and produces 3-dimensional space. That question has an answer. And it was proven as rigorously as anything in the history of physics. In 1993, Gerard 't Hooft took Bekenstein's result and followed it to its conclusion. If information lives on surfaces and fully determines what happens in the volume it encloses, then the three-dimensional universe is equivalent to a two-dimensional dataset. Every object, every distance, every direction is generated from flat data the way a hologram turns a flat film into depth. Leonard Susskind formalized this in 1995. For 4 years, you could still dismiss it as a theoretical curiosity, a restatement that might not correspond to anything real. In 1997, Juan Maldacena made that impossible. He was 29. He published one paper that became the most cited in theoretical physics, over 20,000 citations. What it proved was not a hypothesis. It was a mathematical equivalence. A 5-dimensional space containing gravity is exactly identical to a 4-dimensional surface without gravity. Not approximately. Exactly. Every equation in the higher dimensional description maps perfectly onto the lower dimensional one. Every question about the space with depth has an identical answer on the flat surface. Two descriptions with different dimensions, different forces, different geometries, and they are the same system. This is not a statement about what reality looks like. It is a proof about what reality is. A universe with depth is mathematically indistinguishable from a flat surface without it. Neither version is more true. The room you are in does not have fundamental depth. The distance between your eyes and the wall is not a gap filled with space. It is a value derived from data on a boundary. If you could read that boundary, you would see a flat pattern. No volume, no distance. The three-dimensional world is what that flat pattern looks like from inside. But a projection needs a mechanism. Data on a surface does not assemble itself into three-dimensional experience. Something weaves flat information into the space you move through. And that something turns out to be a phenomenon you already know. You encountered it in the first 15 minutes of this story. Two particles created in a single event, sent flying in opposite directions, correlated across any distance with no signal between them. Bell proved it. Aspect confirmed it. Zeilinger closed the loopholes and collected a Nobel Prize. You heard this 20 minutes ago. At the time, it sounded like a strange property of quantum objects, disturbing but contained. It is not contained. It is the mechanism that builds the space you are sitting in. In 2010, Mark van Raamsdonk used Maldacena's framework to ask what happens when you reduce entanglement between two regions. The space between them stretches. Reduce it further, the space stretches more. Remove it entirely, and the space does not just expand, it tears. The regions are no longer connected, no longer part of the same geometry. The distance between them is not large. It is undefined. There is no between. Entanglement does not happen inside space. Entanglement is what space is made of. In 2013, Susskind and Maldacena showed that an entangled pair of particles and a wormhole are the same object. A wormhole bridges two distant points in space-time. An entangled pair correlates two particles regardless of distance. These are not two phenomena, they are one. The equation is ER equals EPR. Two papers Einstein wrote in the same year, 1935, about what he thought were unrelated subjects, turned out to describe the same thing. The distance from your body to the nearest wall exists because particles in your skin and particles in the plaster share a degree of entanglement. That entanglement generates the spatial relationship. Weaken it and the wall drifts. Sever it and the wall does not move away. The concept of away stops applying. You have lost space. It is not fundamental. It is a projection from flat data, stitched together by entanglement. But space is only half the stage your life plays out on. The other half is time, you age, coffee cools, memories form in one direction only. Time feels like the most real thing you have. The deepest equation in physics says it does not exist. In 1967, Wheeler-DeWitt and John Wheeler wrote the equation that was supposed to unify gravity and quantum mechanics. General relativity handles the large. Quantum mechanics handles the small. Both flawless in their own territory. Neither survives in the other. For decades, physicists looked for one equation containing both. DeWitt and Wheeler found it, and it had a problem no one has solved in over 50 years. There is no variable for time in the equation, not because they forgot, not because they simplified. The equation describes the quantum state of the entire universe, and in that description, time is absent. No before, no after, no flow. The most complete equation we have for reality does not acknowledge that time exists. You feel it right now, reading these words one after another. You remember 10 seconds ago. You expect 10 seconds from now. Your coffee gets cold. Your cells divide and die. Every experience you have ever had sits on a line from past to future, and that line feels as solid as the ground. But you know what happened to the ground. It is a projection held together by entanglement. The hardness was a signal. The Wheeler-DeWitt equation says the same about time. The line from past to future is not a property of the universe. It is something the universe generates for observers who cannot see the whole picture. This lands differently than losing space. You can accept that depth is a projection. Your eyes play tricks. Optical illusions exist. Space being computed feels strange but survivable. Time is different. Time is where your life happens. Your memories sit in the past. Your plans in the future. Your identity depends on the sequence from yesterday to today to tomorrow. If time is not real at the deepest level, then the sequence of your life is not a fact about the universe. It is a sensation, generated by something. Carlo Rovelli, one of the founders of loop quantum gravity, spent years on this. Why does something that does not exist at the fundamental level feel so real from inside? His answer connects to the variable that has been underneath every result since the beginning. Rovelli and the mathematician Alain Connes published the thermal time hypothesis in 1994. It starts with something you already know but have never examined. You cannot see every particle in the room you are in. You cannot track every atom of air, every photon bouncing between surfaces, every quantum state of every electron in the walls. You see a summary, a blur. Your senses hand you a smoothed out picture of a system containing more data than you could process in 1 billion lifetimes. Rovelli argued that this is where time comes from. When you lack complete information about a system, you describe it with probabilities. You assign likelihoods to states you cannot observe, and the math of that process produces something. A parameter that orders states from probable to improbable. That parameter flows. It has a direction. It distinguishes past from future. It appears only because your information is incomplete. You feel this every time you touch a warm cup. The heat is not fundamental. The cup contains trillions of molecules at trillions of speeds. You cannot feel each one. What you feel is their average kinetic energy, temperature, real to you, but non-existent at the level of individual molecules, a consequence of limited access. Time works the same way. You experience a flow from past to future because you cannot see the whole system. If you could track every particle, every entanglement, every correlation simultaneously, the flow would stop. Past and future would dissolve into a static structure. Exactly what the Wheeler-DeWitt equation describes. Time is not a river carrying you forward. It is what the river looks like when you cannot see all the water at once. Space is a projection computed from information. Time is an experience produced by incomplete access to information. The room around you and the moment you are in are both generated by data and shaped by how much of it you can see. You are an observer inside an architecture made of information, and the architecture has settings, constants, numbers that determine whether stars form, whether atoms hold together, whether anything exists at all. Those numbers are tuned with a precision that should not be possible. The gravitational constant determines how strongly matter pulls on matter. It controls whether gas clouds collapse into stars or drift apart into nothing. Increase it by 1 part in 10 to the 60th power, and every star burns too hot and dies too fast for planets to form. Decrease it by the same fraction and matter never clumps. No stars, no galaxies, no chemistry. The number sits on a razor edge 60 decimal places wide. The strong nuclear force holds protons and neutrons together inside nuclei. It determines which elements can exist. Shift it upward by 0.5% and hydrogen fuses too easily. Every atom in the early universe converts to helium before anything interesting happens. Shift it downward by 0.5% and deuterium is unstable. The fusion chain that builds heavy elements inside stars breaks at the first link. No carbon, no oxygen, no U. In 1953, Fred Hoyle was working on how stars forge heavy elements from light ones. He needed carbon to exist. Without it, the chain of elements leading to life cannot form. But the physics said carbon should not be produced in useful quantities. The probabilities were too low. Hoyle made a prediction his colleagues found absurd. He said there must be a specific energy level in the carbon-12 nucleus that dramatically increases carbon production. He predicted it not from theory, but from the fact that we are here. We are made of carbon. Therefore, the resonance must exist. William Fowler tested it at Caltech. The resonance was exactly where Hoyle said. Exactly at the energy needed to make carbon abundant. Hoyle used his own existence as a data point to predict a nuclear physics result, and it was correct. He later said nothing had shaken his atheism as much as this discovery. The number looked like it had been placed there deliberately. One constant tuned to 60 decimal places. Another to 3 significant figures. A nuclear resonance sitting exactly where it must for you to exist. You could call this coincidence. The next number makes that very hard to say. Empty space is not empty. Quantum field theory says the vacuum seethes with energy. Particles flicker in and out of existence on timescales too short to measure. This energy pushes space apart, inflating the universe from within. Physicists can calculate how much vacuum energy there should be. They add up contributions from every quantum field and get a number. Then they compare it to the value actually observed. The two numbers disagree by a factor of 10 to the power of 120. This is the largest discrepancy between prediction and observation in the history of science. The theory says the vacuum should contain enough energy to rip every atom apart instantly. The observation says it is almost zero. Almost, but not quite. A tiny residual, so small it took until 1998 to detect. That year, Saul Perlmutter and Adam Rees independently found that the expansion of the universe is accelerating. The acceleration is driven by this tiny leftover vacuum energy. And that value is fine-tuned to 120 decimal places. Imagine a dial with markings from 0 to 10 to the 120th power. The universe functions only if the dial sits on one specific number. Turn it one click higher and space flies apart so fast that nothing forms. One click lower and the universe collapses before a single star ignites. One value out of 10 to the 120th possibilities allows galaxies, stars, planets, and you. Steven Weinberg predicted in 1987 that this constant would be extremely small, but not zero. A value of exactly zero would need its own explanation. A large value would prevent observers from existing. 11 years later, Perlmutter and Rees found precisely that. Small, not zero. Exactly in the window that permits a universe complex enough to ask why. Two constants tuned to 60 and 120 decimal places. A nuclear resonance positioned with surgical precision. You are inside a system whose parameters should not occur by chance. And the one explanation that could rescue randomness does not hold up. The standard escape is the multiverse, infinitely many universes, each with different constants, and we happen to be in the one that works. We see fine-tuning because only a tuned universe produces observers to notice it. This sounds like a solution. It is not. The multiverse cannot be observed. No telescope, no experiment can detect another universe. It cannot be tested. It cannot be falsified. And the problem runs deeper than testability. The mechanism that generates multiple universes needs its own parameters. Eternal inflation requires specific initial conditions. The string theory landscape contains 10 to the 500th possible vacua, but the selection mechanism is unknown. You have not solved the problem. You have hidden the locked box inside a bigger locked box. Roger Penrose calculated the probability of our universe arising by chance. 1 in 10 to the power of 10 to the power of 123. You would need more zeros to write that number than there are particles in the observable universe. Even an infinite ensemble of random universes does not make this comfortable, because the space of possible configurations is larger than any concept of large your brain can hold. The one mechanism that was supposed to explain part of the tuning has collapsed. The Higgs boson has a mass of 125 billion electron volts. Quantum corrections should push it 15 orders of magnitude higher. Something holds it down. For 40 years, the explanation was supersymmetry, a framework predicting partner particles for every known particle. The Large Hadron Collider ran for 13 years to find them. 3 runs, trillions of collisions at the highest energies ever produced. It found the Higgs. It found nothing else. No partners, no supersymmetry, no explanation. The parameters are set. The escape routes are closed. You are inside an architecture tuned beyond any account of chance, and no known framework can say why. There is one more place to look. Not outward at the universe, inward, at the structure of knowledge itself. In 1931, a 25-year-old mathematician in Vienna published a paper that destroyed the foundations of his own field. Kurt Gödel was quiet, meticulous, and terrified of making errors. He checked his work obsessively, and what his work showed was that the project at the center of early 20th century mathematics, the effort to place all of knowledge on a solid, provable foundation, was impossible. Gödel proved that in any formal system powerful enough to describe basic arithmetic, there will always be statements that are true but cannot be proven within the system. Not because the proof is hard to find, not because mathematicians are not clever enough, because the structure of the system forbids it. The limitation is not in the people working on the problem. It is in the problem itself. This is not a technicality. Arithmetic is the backbone of every calculation, every model, every simulation, every physical theory ever written. If the language that physics uses to describe reality has built-in blind spots, then the description of reality has the same blind spots. There are true things about the universe that cannot be derived from any set of axioms, no matter how complete those axioms appear. You have spent the last 30 minutes learning that reality is made of information, that space and time are generated by that information, and that the parameters of the system are set with impossible precision. The natural question is why? Why these constants? Why this architecture? Why anything at all? Gödel's answer is not that the question is too hard. His answer is that some true statements about a system cannot be reached from inside that system. You are inside this system. You are made of the same information that the system runs on. And the proof says that your position inside it permanently blocks certain truths from your reach. This could feel like a minor inconvenience, a few blind spots in an otherwise clear picture. The mathematics is beautiful, the experiments work, the models predict. So what if there are a handful of questions that remain forever open? The next result shows why that comfort is an illusion. Gregory Chaitin grew up in the generation after Gödel and asked what seemed like a natural follow-up question. Gödel proved that blind spots exist. Chaitin wanted to know how many there are. The answer is that there are more blind spots than visible territory. Infinitely more. Chaitin developed a branch of mathematics called algorithmic information theory, and at its center sits a number he named omega. Omega is a real number, as concrete as pi or the square root of 2. It is precisely defined. You can write the formula that specifies it. And every digit after the decimal point contains the answer to a question about whether a particular computer program will halt or run forever. These are not abstract puzzles. The halting problem connects to every question about computability, prediction, and the limits of knowledge. Omega contains all the answers, and omega is uncomputable. Its digits are random, not random in the sense that we lack the tools to find the pattern. Random in the provable, mathematical sense that no pattern exists. Each digit is independent of every other digit. No algorithm, no shortcut, no intelligence of any kind can calculate them. This means the truths Gödel said you cannot prove are not rare exceptions. They are the majority. For every theorem you can derive from a set of axioms, there are infinitely many true statements that no derivation will ever reach. The visible portion of mathematical truth, the part you can prove and publish and build technology on, is a thin film stretched over an ocean of the permanently inaccessible. Go back to the fine-tuning problem. The constants of the universe are set to values that no theory can explain. It is possible that an explanation exists. It is also possible, and Chaitin's work makes this precise, that the explanation is one of the truths locked behind the boundary. Real, definite, and permanently out of reach for any intelligence operating inside the system. You might still hold on to one hope. Even if you cannot prove everything, even if most truth is hidden, at least you can predict. If you know the rules of a system, you can run them forward and see what happens next. You can simulate. You can forecast. That hope has a limit too. Stephen Wolfram spent decades studying systems built from simple rules. Cellular automata. Programs consisting of one instruction applied repeatedly to a grid. Some produce patterns indistinguishable from randomness. Wolfram proved that for certain classes of these systems, no shortcut exists. No formula jumps from initial state to final state without running every step in between. The only way to find out what the system does is to let it run. Full speed, full resolution. You cannot skip ahead. You cannot compress the process. He called this computational irreducibility. If the universe is a computational system, which everything you have heard so far suggests, then it may be irreducible. Even holding the complete source code of reality, every rule, every parameter, you could not fast forward. You could not calculate next Tuesday without living through every moment between now and then. The future is not hidden because you lack data. It is hidden because the computation cannot be shortened. 3 limits on knowledge. Gödel says you cannot prove everything from inside the system. Chaitin says the unprovable vastly outnumbers the provable. Wolfram says even complete knowledge of the rules does not let you skip ahead. 3 locks. None of them can be picked. And yet mathematics works. It works so well it should not. In 1928, Paul Dirac wrote an equation predicting a particle no one had seen. 4 years later, Carl Anderson found it. Antimatter. In 1915, Einstein published equations for how gravity bends space-time. 100 years later, LIGO detected gravitational waves, matching his predictions to 12 decimal places. In 1960, Eugene Wigner asked a question no one has answered. Why does mathematics, an abstract game with symbols on paper, describe the physical universe with this precision? He called it the unreasonable effectiveness of mathematics. The language has blind spots. Most truth is locked away. The future cannot be compressed. But the language fits reality like a key in a lock. As if reality were written in mathematics. As if the thing and the description of the thing are not separate. 5 paths. Observation, information, space-time, fine-tuning, knowledge, all converging. Time to see where they meet. You started with a particle that changes behavior when observed. You move to information that has physical weight. You watch space dissolve into a hologram sewn by entanglement. You watch time dissolve into a statistical artifact of incomplete access. You learned that the numbers holding all of it together are tuned to a precision no theory explains. And you learn that the tools you use to understand any of this have hard limits built into their structure. These are not 5 separate findings, they are 5 entrances to the same room. Quantum mechanics says reality depends on the observer. Information physics says reality is made of data. The holographic principle says space is a projection. Fine-tuning says the parameters are set. Mathematics says the description fits reality so well, the two may not be distinct, while proving that no description from inside can ever be complete. Each field developed independently. The physicists running Bell tests were not talking to the mathematicians proving incompleteness. The cosmologists measuring the cosmological constant were not collaborating with information theorists at IBM. Different methods, different instruments, different decades, different problems, and results that placed side by side describe the same object. That object has properties, finite resolution, set parameters, dependence on observation to take definite form, information as substrate, built-in limits on what can be known from the inside. A language its inhabitants can partially read but never fully decode. You recognize this list, not from a physics lecture, from your daily life. Finite resolution, set parameters, observation dependence, information base, access limits, partial readability. This is a technical specification, the description of a system that was configured. Not grown, not accident, configured. The question is, what kind of system? And the most common answer is the wrong one. The word most people reach for is simulation. In 2003, Nick Bostrom framed it as statistics. If any civilization ever runs detailed simulations of minds, the simulated will vastly outnumber the originals, trillions to 1. If you are randomly drawn from the total pool of conscious beings, the odds you are original are nearly 0. Therefore, you are almost certainly simulated. The logic is valid, the statistics are clean, and the frame is almost certainly wrong. Simulation implies a computer. A computer implies a builder. A builder implies an outside, a room where the machine sits and the operator watches. The word takes the most radical discovery in the history of science and stuffs it into a familiar box. Some kid in a basement running a program. Some civilization with a large server farm. Simulation lets you keep your assumptions about external, solid, objective reality and simply add a layer. There is still a real world out there, you tell yourself. We just happen to be in the copy. The data does not support this. Nothing in quantum mechanics, information theory, or the holographic principle requires an outside. Nothing requires a builder. Nothing requires a machine. What the data describes is a system that generates itself through observation. Properties do not exist until measured. Space is woven from correlations, not built from material. Time emerges from the limitations of observers, not from an external clock. This is not a simulation of something else. If it were, the something else would need the same rules and you would face the same questions one level up. The data points somewhere stranger. A system that does not copy reality. A system that is reality, with no original to compare it to, no outside, no reference frame beyond the one you are standing in. And this system has a very specific way of deciding what becomes real and what does not. A physicist named Wojciech Zurek spent 20 years working out how it operates. Zurek's framework is called quantum Darwinism. It answers a question hiding under every experiment since the double slit. If particles have no definite properties until observed, why does the world look solid? Why does the chair hold your weight? Why does coffee taste the same every morning? Why is the large-scale world so stable when the small-scale world is not? The answer is selection. When a quantum system interacts with its environment, information about its state spreads into surrounding particles. Air molecules, photons, thermal vibrations, all receive copies. But not all states copy equally well. Some are fragile. Their information degrades as it spreads. Others are robust. They stamp redundant copies across thousands of environmental channels. These survivors become real. Everything else vanishes. This is natural selection applied to information. The states you see, the position of a chair, the color of a wall, are not chosen by you. They are the winners. The states that reproduce their information most effectively are the ones you get to observe. Every superposition, every quantum possibility that failed to copy itself widely enough is called. Not because it does not exist, because it did not survive. Go back to the double slit. The particle takes both paths when no information about it reaches the environment. The moment that information begins copying into surrounding particles, superposition collapses. Not because you looked, because the environment selected one outcome. Your observation is the last step in a process already underway. Reality renders itself through the same logic as evolution. In biology, fitness is reproductive success. In physics, fitness is informational redundancy. States that stamp the most copies into their environment become real. The rest never solidify. The system does not produce all of reality all the time. It produces what survives observation. It renders on demand. And the entity doing the final reading, the observer at the center of every experiment and every theory you have heard tonight, is you. Your consciousness. The one thing none of these theories can explain. Every result tonight depends on the observer. The particle does not commit without one. The eraser works because information is accessible to one. Space and time emerge from the limitations of one. Fine-tuning is visible only because one exists. Zurich's framework runs entirely on the question of what is accessible to observers. The observer is the load-bearing wall of this structure. Remove it, and nothing holds. And physics cannot tell you what an observer is. In 1995, David Chalmers named the problem neuroscience had been stepping around for decades. The hard problem of consciousness. The easy problems are not easy in the casual sense, they are immensely complex. How the brain processes vision, stores memory, coordinates movement, generates language. These are engineering problems. You can map the wiring, you can trace signals, you can build models that replicate the function. The hard problem is different. It asks why any of this processing is accompanied by experience. You see red. There is something it is like to see red. A quality. An interior event no brain scan can capture. A neuroscientist can map every synapse that fires when you see a sunset. She can name the wavelengths, the neurons, the chemicals. She can describe the entire process in exhaustive detail. None of it explains why there is experience attached. Why it feels like something to be you. Physical processes describe what happens. Consciousness is what it is like. Between those categories, there is no bridge in current physics, not a bridge unbuilt. A gap where no bridge can go, because the materials do not exist in the framework. Every physical law describes relationships between measurable quantities. Consciousness is not a measurable quantity. It is the thing that measures. You are the observer. The entire structure depends on. The best science available cannot tell you what you are. One theory tries. Giulio Tononi is a neuroscientist who refused to accept that consciousness is what happens when a brain gets complicated enough. Complexity is not an explanation. A hurricane is complex. A galaxy is complex. Neither experiences anything. Tononi wanted a theory that says precisely why some systems have interior experience and others do not. He published it in 2004, Integrated Information Theory. The core idea is a quantity called phi. It measures how much information a system generates beyond what its parts produce independently. Split a system in half and lose nothing, phi is 0. No integration, no unity, no experience. But if splitting destroys information that existed only in the connections between parts, phi is positive. The system has something its components lack. Tononi's claim is that this something is consciousness. Phi is not a metaphor. It is a number you can calculate for any system with defined structure. A thermostat has a tiny phi. A brain has an enormous one. And the theory predicts something that unsettles most neuroscientists. If phi is consciousness, then consciousness is not limited to brains. Any sufficiently integrated information system has some degree of experience, a network, a colony, potentially a planet-scale web of interacting particles. Consciousness is not a product of biology. It is a property of information structured in a specific way. Wheeler said reality is information. Tononi says consciousness is a property of integrated information. If both are right, then consciousness did not appear inside reality as a late addition. It is woven into reality at the level of information itself, there before brains, before biology, before Earth, as fundamental as entropy or charge, not floating on top of physics. Inside it, one physicist took this seriously enough to build a mechanism. He proposed that consciousness does not merely observe quantum events, it participates in them, and the evidence, against expectations, started to support him. Roger Penrose won the Nobel Prize in 2020 for his work on black holes. He is not a fringe figure, and for 30 years, he has argued that consciousness is directly connected to quantum behavior. Not as an observer watching from outside, as a participant inside the process. The idea starts with collapse. A particle exists in superposition until something causes it to choose. The standard answer for what causes this is vague. Penrose rejected it. He proposed that gravity forces the collapse. When a superposition involves enough mass to create a measurable difference in space-time geometry, it becomes unstable. It collapses on its own. Not because anyone measured it, because space cannot hold two contradictory configurations of matter past a threshold. This is objective reduction. Stuart Hameroff, an anesthesiologist, added the biological piece. Inside every neuron are microtubules, tiny protein structures that Hameroff had studied for years. He proposed that quantum states persist inside these tubes long enough for Penrose's collapse to occur in a controlled way. The brain does not just process information like a transistor. It sustains quantum superpositions in its own cellular architecture. When those superpositions hit the gravitational threshold, they collapse. That collapse is a moment of consciousness. Each experience is a quantum gravitational event, orchestrated by the structure of your neurons. For years, this was dismissed. The brain is warm and wet. Quantum coherence should not survive there. Then, in 2014, Anirban Bandyopadhyay detected quantum vibrations in microtubules at frequencies matching the predictions. The objection began to crack. The circle closes. Reality depends on observation. Observation requires consciousness. Consciousness may be a quantum gravitational process inside the brain. Quantum gravity is the deepest layer of reality we can reach. The observer and the observed are not separate. They are one system at different scales. And one man saw this before anyone else did. John Wheeler. Again, the man who named black holes. Who said it from bit. Who designed the delayed choice experiment, proving the present rewrites the past. At the end of his life, Wheeler pulled all of these threads into one statement: the participatory universe. The universe does not exist out there, independent, waiting for someone to look at it. Observation is not passive, it is constitutive. It brings reality into being. Not in the mystical sense that your thoughts shape the world. In the experimental sense that quantum mechanics has demonstrated for a century. Properties do not exist until measured. The past is not fixed until the present observes it. Space is woven from entanglement between observed quantities. Time emerges from the limits of what an observer can access. The observer is not reading a book already written. The observer is writing it by reading it. Wheeler drew a diagram. A large U. At one end, the Big Bang. At the other, an eye looking back. The eye is the observer. The line connecting them is the history of the universe. But the line does not exist without the eye. The observer at the end of time reaches back and participates in defining the conditions at the beginning. The universe created consciousness. Consciousness, through observation, creates the universe. This is not a metaphor from a popular lecture. This is the conclusion of a career spanning 60 years of physics. Wheeler believed the participatory principle was not one interpretation among many. He believed it was the only one consistent with evidence. You are not inside a machine built by someone else. You're not watching a show scripted before you arrived. You are a participant in a process that produces no definite outcomes until you engage. The system needs you. Without observers, no collapse. Without collapse, no definite states. Without definite states, no universe. Just an infinite cloud of possibility that never becomes anything. This is the most radical claim in the history of physics, and it carries a trap set a century ago. If you are the observer, and the system exists through your observation, then you are inside the thing you are creating. You cannot step outside. There is no balcony, no view from above. You are embedded in the computation, made of the same information the computation runs on. And Gödel proved what this means. You cannot see the complete picture from inside. Not because your instruments are weak, not because you need more time or intelligence, because the structure of any system complex enough to contain you prevents you from proving all truths about itself. The blind spots are not mistakes. They are architecture. You are standing in a building whose blueprint includes rooms you will never find. Chaitin showed you the scale. The rooms you cannot find outnumber the ones you can. Infinitely. Every theorem, every law, every prediction in the history of science is a thin, bright line drawn across a darkness that extends without limit. Wolfram closed the last exit. Even if you held the full blueprint, every rule, every constant, you could not use it to see ahead. The only way to know what the system does next is to be the system doing it. No shortcuts, no compression. You are inside a self-observing loop. The loop created you so that you could observe it into existence. And from inside, you will never see the whole structure. Not in 1,000 years, not with instruments the size of galaxies. The limitation is not practical, it is mathematical. Gödel's theorem is not a conjecture. It is a proof as solid as the proof that there are infinitely many primes. It will never be wrong. You are the reason the universe exists in definite form, and you are permanently inside it, not locked in a cage with breakable walls. Locked in a cage where the walls are made of you. The door would need to open into a place that does not exist. There is no outside. The word requires a reference frame beyond the system, and you are the reference frame. Everything you will ever see, think, measure, or imagine is inside. And inside is not enough. This is the bottom of the spiral. One more way to see it remains. Christopher Fuchs is a quantum physicist who spent years on the foundations of quantum mechanics and arrived at a conclusion most colleagues find difficult to sit with. His framework is called cubism. It does not soften what you have heard tonight. It sharpens it. Standard quantum mechanics treats the wave function as a description of reality. Cubism says this is wrong. The wave function does not describe the particle. It describes what you, the observer, should expect when you interact with the particle. It is not about the world. It is about your relationship to the world. There is no view from nowhere, no objective quantum state independent of all observers. Every measurement is an interaction between an agent and a system. The result belongs to the agent, not to the universe at large. This does not mean reality is subjective. Fuchs is emphatic. Something is out there. But what is out there has no single observer-independent description. Each observer has a different relationship to it. Each experience is irreducibly personal. There is no master document containing the complete state of reality as seen from no particular viewpoint. Carlo Rovelli reached the same place through a different path. His relational quantum mechanics says properties of a system are not intrinsic. A particle does not have a position. It has a position relative to another system interacting with it. Change the system, the position changes. No absolute state hides underneath the relative ones. The relative ones are all there is. You are not looking at reality through a window that could be cleaned to give a perfect view. You are in a conversation with something that responds differently depending on how you ask. The conversation is real. The responses are real. But there is no transcript capturing what reality says to everyone at once. Only what it says to you. The room around you. The time passing. The distance to the wall. All of it is your conversation with a system that has no center and no view of itself that includes all others. You are not locked out of the truth. You are the truth, looking at itself from one angle, in a structure where no single angle sees the whole. Everything you have heard points to a system with rules, set parameters, finite resolution, information as substrate, observer dependence all the way down. The natural impulse is to ask who set the parameters. The question assumes a designer, an intelligence that precedes the system and chose the numbers. But there is a version of this story that needs no designer, and it is just as unsettling. In 1992, Lee Smolin proposed that universes reproduce. The mechanism is black holes. When matter collapses past the point of no return, the conditions inside may trigger a new expansion. A new Big Bang. A new universe budding off from the old one like a cell dividing. The new universe does not inherit its parents' constants exactly. The parameters mutate. Slightly different gravity. Slightly different strong force. Small variations like genetic mutations. Universes that produce the most black holes produce the most offspring. Universes that produce the most black holes are the ones with constants tuned to create stars, because stars collapse into black holes. Stars also forge heavy elements. Heavy elements create chemistry. Chemistry creates life. Life creates observers. The fine-tuning is not a designer selecting from a menu. It is selection pressure across generations of universes. The constants are tuned because tuned universes reproduce. Untuned ones die childless. Over billions of cycles, survivors converge on parameters that maximize complexity. You live inside a universe that won a cosmic version of natural selection. Not because anyone chose it, because it outbred the alternatives. This does not make the architecture less strange. A system that reproduces, mutates, and evolves is not simpler than one that was designed. It is more autonomous. It does not need an external builder, because it builds itself. Generation after generation. Each cycle producing a universe slightly better at producing the next. And the information encoding those parameters has a property that makes all of this possible. Information cannot be destroyed. This is not a philosophical preference. It is a law. Quantum mechanics requires it. The equations describing how particles interact are unitary, reversible. Every process that transforms a quantum state can in principle be run backward to recover the original. No data is lost, ever, under any conditions. This created one of the longest arguments in physics. In 1974, Hawking proved that black holes radiate. They shrink. They evaporate. When a black hole evaporates completely, everything that fell in, every star, every atom, every quantum state seems to vanish with it. Hawking said it did. He argued that black holes destroy information, that they are the one exception to the conservation law. For 30 years, the field split. Hawking on one side, Susskind and 't Hooft on the other, insisting the math does not allow destruction. In 2004, Hawking conceded. He was wrong. The information survives. The resolution came from the holographic principle. Information falling into a black hole is not stored in the interior. It is encoded on the event horizon. As the hole radiates, information leaks out in subtle correlations between emitted particles. In 2019, Almhiri, Pennington, and others proved this rigorously using the island formula. Every bit that falls in comes back out. The black hole is not a furnace, it is a scrambler. It takes ordered data, tangles it beyond easy recognition, and releases it slowly across the lifetime of the evaporation. The most extreme object in the universe, an object whose gravity traps light itself, cannot erase a single bit of data. Information is more fundamental than gravity, more durable than space-time, more permanent than matter. It is the last thing standing when everything else has been torn apart. If information survives the death of a black hole, the question becomes whether it survives something larger. Whether data can cross the boundary between one universe and the next. Penrose proposed that it can. His framework is called conformal cyclic cosmology. It begins at the end, not the end of Earth or the Sun, the end of everything. Trillions of years from now, every star burns out, every black hole evaporates, every particle drifts beyond reach of every other. The universe hits maximum entropy. Nothing happens, nothing can happen. Time stops. This is heat death, the consensus prediction of modern cosmology. The universe ends not with a bang, but with infinite featureless stillness. Penrose looked at this endpoint and noticed something no one had. A universe at maximum entropy, with no massive particles, with nothing but radiation in infinitely diluted space, is conformally identical to the conditions right after the Big Bang. The geometry of the end and the geometry of the beginning are the same structure at different scales. The death of one universe is indistinguishable from the birth of the next. If correct, the universe does not end. It cycles. Death of one aeon is birth of the next. And information leaks through, not as blueprints, as subtle patterns imprinted in radiation, filling the new universe at the moment of its birth. Penrose predicted specific signatures, concentric rings of uniform temperature in the cosmic microwave background, left by black hole collisions in the previous aeon. In 2010 and 2020, Penrose and Gazardian published analyses of WMAP and Planck satellite data claiming to have found them. The results are disputed. The mainstream has not accepted them, but the patterns are in the data. Information survives black holes. It may survive universes. The system you are in is not a single event. It is a cycle, a loop that runs, resets, runs again. Runs, each iteration carrying traces of what came before. You are living inside one pass of a process with no clear beginning and no clear end. The constants, the forces, the architecture of your universe may be an inheritance from a cosmos that died before yours was born. This answers how. It does not answer why. Why does anything exist at all? Gottfried Wilhelm Leibniz asked this in 1714. 3 centuries later, it remains the one question that no discipline has touched. Physics can tell you how gravity works. It cannot tell you why there is gravity rather than nothing. Mathematics can describe the structure of the universe with extraordinary precision. It cannot say why there is a universe for the structure to describe. Neuroscience can map every synapse in your brain. It cannot explain why that mapping is accompanied by the experience of being alive. Ludwig Wittgenstein, in the last line of his Tractatus, put it as plainly as language allows. It is not how things are in the world that is mystical. It is that the world exists at all. You have followed 5 paths through the architecture of reality. You have seen that it is made of information. That space is a projection and time is a statistical artifact. That the parameters are set with precision beyond any reasonable account of chance. That the system depends on observation to take definite form. That knowledge of the system from inside is provably limited. And that the whole structure may cycle through death and rebirth, carrying information from one iteration to the next. Every one of these results answers a how question. How does reality behave when observed? How is space constructed? How are the constants set? How does consciousness relate to physics? How does information persist? But the why sits behind all of them, untouched. Why is there information rather than no information? Why is there a system at all? Why is there something rather than nothing? Gödel's theorem applies here with full force. You are inside the system. The question, why does this system exist, is a question about the system from outside the system, and there is no outside. The question is not unanswered. It is unanswerable from your position. Not because you are limited, because the question requires a vantage point that the architecture of reality does not contain. It is a true statement that cannot be proven from within. Gödel's ghost, standing at the end of every road you have walked tonight. This is the wall. You can see it. You can describe its texture. You can measure its height. You cannot see what is on the other side. And the wall is not a failure of science. It is a feature of the system. It was always here. You just did not know what you were looking at until now. You fire a particle at a wall and it goes through 2 slits at once. You place a sensor and it picks one. You erase the record and it goes through both again. You delay the choice and the present rewrites the past. You separate 2 particles by kilometers and they correlate instantly, as if distance is not real. Information has physical weight. Erasing a bit produces heat. The universe has performed 10 to the 120th operations since it began. Matter is a pattern in that computation. Maximum data in a volume is set by the surface, not the interior. Space is a projection from flat data. The projection is held together by entanglement. Time does not appear in the deepest equation. Your experience of it is a side effect of partial access. Gravity tuned to 60 decimal places. The cosmological constant to 120. Supersymmetry does not exist. The multiverse is untestable. Gödel proved truth outruns proof. Chaitin proved most truth is permanently sealed. Wolfram proved total knowledge does not let you skip ahead. And mathematics describes a reality so precisely that the two may not be separate. 5 paths converge. The system renders on demand. Consciousness is woven into the fabric. The loop closes. The universe creates consciousness so consciousness can observe the universe into existence. And the trap. You are inside the loop. You cannot exit. The walls are made of you. The question why has no answer from your position. Not because the answer does not exist, because your position is the wrong side of a boundary that cannot be crossed. Everything tonight is verified, proven or derived from things that are. None of it is speculation, all of it says one thing. You are inside a system with rules, limits, parameters, and an observer at its center. That observer is you. The system does not exist without you. That last part is not the horror. That last part is the way out. Go back to Wheeler, the participatory universe, the diagram with the you, the I at the end of time that gives shape to everything that came before it. If reality does not exist in definite form without an observer, then the observer is not a victim of the system. The observer is the condition for the system's existence. You are not trapped inside a structure that was built before you arrived. You are the reason the structure is here. Without you, without observers like you, there is no collapse. Without collapse, no definite states. Without definite states, no atoms, no stars, no planets, no architecture. Just a fog of superposition that never becomes anything. The horror of the last hour was real. You are inside a system you cannot fully understand. The walls are made of you, and you cannot leave. The question why will never be answered from here. Gödel is not going away. Chaitin is not going away. The locked rooms will stay locked. But look at what that means from the other direction. The system that you cannot escape is also the system that cannot exist without you. The trap is mutual. You need the universe to exist in. The universe needs you to exist at all. You are not a prisoner. You are a condition. The most fundamental condition. More fundamental than gravity. More fundamental than space-time. More fundamental than information itself. Because without an observer, information never collapses into anything definite. It remains potential, unrealized. A book with no reader. You have spent your whole life assuming you are a small thing inside a large thing. A speck of biology on a rock orbiting an average star in an unremarkable galaxy. Physics says the hierarchy is reversed. The speck is what makes the galaxy real. The observer is not inside the universe the way a fish is inside a tank. The observer is inside the universe the way a reader is inside a story. Without the reader, the words are just ink. This is not comfort. This is not a motivational speech stitched onto the end of a science lecture. This is what the equations say. The participatory principle, the measurement problem, the collapse postulate, the role of the observer in every single formulation of quantum mechanics ever written. You are not optional. You are load-bearing. The question now is what that means for the life you are actually living. In 1995, Álvaro Pascual León ran an experiment no one expected to work. Two groups learned a 5-finger piano exercise. One practiced on a real keyboard 2 hours a day for 5 days. The other sat in front of the keyboard and imagined playing. Same duration, same schedule. They never touched the keys. At the end, Pascual León scanned both groups. The physical practitioners showed reorganized motor cortex, new pathways, expanded finger control regions. Expected. Practice changes the brain. The imaginary practitioners showed the same changes, same expansion, same new connections. They had altered the physical structure of their brains by paying attention to an internal representation. Nothing more. This is not a metaphor for positive thinking. It is a measurement. A scan showing that directed attention rewires the physical organ doing the observing. The observer changes the observed. Not at the quantum scale, not in a laboratory. In your skull. Every day. Michael Merzenich mapped this across decades. The brain is not a fixed machine. It restructures itself based on what you attend to. Focus on a sound and the auditory cortex expands the region for that frequency. Focus on a movement and the motor cortex reshapes around it. Stop focusing and the region contracts. The architecture of your brain at this moment is the accumulated result of everything you have chosen to observe throughout your life. You started tonight with a particle that changes when you look at it. You end with a brain that changes when you direct attention. The principle operates at both scales. Observation is not passive. It alters the system being observed. In quantum mechanics, it collapses superposition. In neuroscience, it reshapes tissue. The observer does not float above reality. The observer reaches in and leaves marks. If consciousness is fundamental, as Tononi and Wheeler and Penrose argued from different directions, this is not a coincidence. It is the same phenomenon at two scales. Your attention is not a spotlight on a fixed world. It is a force that participates in building the world. Every morning you open your eyes, you are not receiving a picture. You are generating one. Wheeler said reality is information. Tononi said consciousness is what integrated information feels like from the inside. Wigner said mathematics and reality fit so tightly they may be the same thing. Place these three next to each other and something emerges that none achieves alone. If reality is information, and consciousness is a property of information structured past a threshold, then consciousness did not arrive after billions of years of evolution. It was always available. Wherever information integrates sufficiently, there is experience. Not thought, not intelligence, the raw fact of something it is like to be a system. This does not require a brain. It requires a pattern. The universe has been producing patterns since the first second after the Big Bang. If mathematics describes reality not as approximation but as identity, if map and territory are the same object in two notations, then the structure of reality is not arbitrary. It follows from something, not from a designer, not from chance, from the same necessity that makes 2 + 2 = 4. The constants are not chosen, they are derived. You cannot see the derivation because you are inside the system, and Gödel blocks the view. But the derivation exists. The effectiveness of mathematics is not unreasonable. It is inevitable if reality and mathematics are two faces of one structure. If the observer collapses information into definite form, then every act of consciousness is an act of creation, not in the grand cosmic sense, in the local, physical sense. You look at a cup and the cup becomes definite. You attend to a memory and the pathways encoding it strengthen. You observe one thing rather than another, and what you observe solidifies while alternatives fade. This is happening now, with every word you read, with every shift of attention. You are a point where the universe becomes specific. There is no separation between you and the system. You are the system experiencing itself. The information making up your consciousness is the same information making up space, time, particles, one substrate. And you are the point where that substrate knows it exists. Here is what you do not know. You do not know what reality is. You know it is made of information. You know it depends on observation. You know it has rules. You do not know what it is. You do not know why it exists. Leibniz asked 300 years ago. Wittgenstein called it the only real question. Every experiment you have heard tonight tells you how. None of them touch why. The question sits behind a wall that Gödel proved cannot be climbed from this side. You do not know what consciousness is. You know it is at the center of every physical theory that describes reality. You know it may be a fundamental property of information. You know your brain reshapes itself around it. But you do not know what it is made of, where it comes from, or why it exists. The hard problem remains hard. Chalmers named it 30 years ago, and not 1 inch of progress has been made on the core question. Why is there experience? You do not know if there is an outside. Wheeler says the universe is a self-observing loop. Cubism says there is no view from nowhere. Gödel says you cannot prove all truths from within. Maybe there is something beyond the system. Maybe the word beyond has no referent. You do not know. You do not know what happens next. Wolfram proved that even complete knowledge of the rules does not let you compress the future. You cannot skip ahead. You cannot see around the corner. The system computes itself at the speed of living, and no perspective available to you can outrun it. These are not temporary gaps in understanding. They are not questions that will be answered by a better telescope, or a faster computer, or a smarter generation. They are structural features of your position inside the system. The darkness is not going away. It is part of the architecture. It is the room Gödel proved you cannot enter. And this is the most honest thing that can be said about your situation. You are standing inside a system that is stranger, more precise, more dependent on you, and more fundamentally mysterious than anything any human being has ever imagined in any story, religion, or philosophy. The mystery is not a gap in knowledge. The mystery is the ground you are standing on. It was always there. You're only now seeing its shape. The question is what you do with that. Tomorrow morning, you will wake up. The light will come through the window the way it always does. You will feel the weight of your body on the mattress. You will hear sounds from outside, traffic or birds or wind, and your brain will assemble them into a familiar world without asking your permission. Everything will feel normal, solid, ordinary. The coffee will taste the way it tasted yesterday, but you will know something you did not know before. You will know that the light coming through the window is electromagnetic information that does not become color until your visual cortex processes it. That the weight you feel is not contact between your body and the bed, but electromagnetic repulsion between electron clouds that never touch. That the sounds are pressure waves in air that do not become meaningful until your auditory system integrates them into patterns. That the solidity of the world is a rendering, generated on demand, by a system that produces definite reality only where and when an observer is present. You will know that the space between your bed and the door is not a void filled with distance. It is a value computed from entanglement between particles in your body and particles in the doorframe. That the time passing as you make coffee is not a river carrying you forward, but a statistical artifact of your incomplete access to the quantum state of the room. That the constants holding the atoms of the cup together are tuned to a precision of 120 decimal places, and no one knows why. You will know that the mathematics describing all of this has limits that cannot be broken. That most truth is permanently out of reach. That the future cannot be compressed or predicted. that the question of why any of this exists has no answer available from inside the system. And you will know one more thing. You will know that without you, none of it is definite. The particles in the wall do not choose a state until something observes them. The space in the room does not exist until entanglement generates it for an observer. The time you feel passing exists because you are a limited being who cannot see the whole picture. And that limitation is what creates the experience of being alive in a moment. The universe is 13.8 billion years old. It has been running for 10 to the 120th operations. It has produced trillions of stars, billions of galaxies, and at least one nervous system complex enough to look back at all of it and ask what it means. That nervous system is yours, not humanity's in the abstract. Yours. The specific pattern of information that is reading these words, processing them, feeling something in response. Physics says you are not a bystander. You are a participant. The system does not produce a definite world without you. This is not a burden. This is what it means to be real in a universe that only becomes real through observation. Every time you look at something, you are completing a process that started with the Big Bang. Every act of attention is the universe choosing to become specific, rather than remaining a cloud of possibilities. You are not small. You are not insignificant. You are not a speck on a rock. You are the point where 13.8 billion years of information processing becomes aware of itself. The mystery will not go away. The locked rooms will stay locked. The wall behind the wall will remain. You will never know why. You will live your entire life inside a system that is more extraordinary than any answer could make it. And the deepest layers of that system will stay just out of reach, visible but untouchable like stars. That is not a tragedy. That is the condition of being the observer, the one the system cannot do without. Go make your coffee, open the door, walk outside. The universe is waiting for you to look at it so it can decide what to be today.